Okay, so hi there, folks. We're now on our next video in college algebra, and now we're going to talk about and deal with the multiplication of radicals. So here, we will learn how to multiply radicals properly. So remember a radical is the one with the squared symbol or with the radical symbol in general. And we're going to talk about this in two parts. First part is how to multiply radicals with the same index, and the second part, which will be after this, we will multiply radicals with the different indices. So we'll start with here first. So to multiply radicals with the same index, what we're going to do is simply, since the indices are the same, we will just multiply the radicands inside those indices, and what we'll have is the product, which is the the product of the factors a and b. So let's have this as our first example. So we have 2 cube root of 5 times 3 cube root of 2. So what we're going to do is to multiply in manners like this. What we will do actually is we're going to um somehow treat this radical as a variable x. Okay, we'll somehow treat this as a variable x in such a way that these 3 here, okay, and this product and this 2 here will serve as coefficients. Okay, they will serve as coefficients. So in multiplying um terms, we will be multiplying the coefficients separately from the factors. So in such a way, this will become like this. So this becomes 2 times 3 is 6. And then what we'll have is, by the theorem here, or by the procedure here, so since they have the same index, which is 3, what we're going to do is to put them under the cube root of 3. And that will have what we'll have is 5 times 2. And we know 5 times 2 is equal to 10. So therefore, our answer here is going to be 6 cube root of 10. Okay, and that's going to be our final answer for number one. Okay, I hope that comes out clean for everyone. So let's proceed to the second example so that we'll have more examples. So for the second example, what we have here is 3/4 root of a squared b times 4th root of a squared b squared. So since there's only one coefficient here, which is 3, just copy that. Okay, what can we do with that? Nothing. Okay, and then what we'll have is the 4th root. Since they are both in the 4th root of these, these radicals are both in the 4th root, so let's put them under 1/4 root of, we're going to multiply a squared b, sorry, a squared b times a squared b squared. With that, let's simplify with it, which is inside the squared symbol or the radical symbol, which is the radicand. So let's simplify that. So we have 3/4 root of a squared times a squared is going to give us a to the 4th. Okay, and then what we'll have here is going to be b times b squared is going to give us b cubed. Okay, that's going to give us b cubed. Okay, and well, after that, we can see that we can somehow, by one law or one simplification in radicals, we can, since they are both the I mean the exponent here inside of the radicand and the index is the same, so we can extract this a to the 4th. Okay, we're going to get the 4th root of a to the 4th. Remember that the 4th root of a to the 4th is equal to a. Okay, so what we'll have is we're going to extract that outside. So what we have is 3 3a, this becomes 3a, and then 4th root of b cubed, and that will be our final answer for our number 2 solution. Okay, so that's for our number 2. Okay, moving on for our last number for letter A. So we have here two binomials. They are square root of 3 plus square root of 2 times square root of 3 plus square root of 2. They're the same. So we can actually write this as square root of 3 plus square root of 2 quantity squared. Okay, so it's like that. So extracting them or factoring them into two binomial. So we have here. So we're going to make use of the FOIL method, shall we? FOIL. First, square root of 3 times square root of 3. If you want, we can put that one by one. So square root of 3 times square root of 3. Let's okay. Let's write that one by one. I'll use this spot here, or here, so that the space will be bigger. So what we'll have is square root of 3 times square root of 3. That's for the first. Outer square root of 3 times square root of 2. So that's going to be a plus. So there's no negative here. So let's use of the plus. Square root of 3 times square root of 2. That's our outer. Now for the inner, that's the same thing, plus square root of 2 times square root of 3. Okay, and then what the last is square root of 2 times square root of 2, so that's going to be still plus square root of 2 times square root of 2. Now by our law that they have the same index, so we can just multiply the radicands. So here, so I mean, they all are under the square root, right? Or the second root. So we have here 3 times 3 is 9, plus 3 times 2 is square root of 6. Here another square root of 6, because 2 times 3 is also 6. And then what we have here is plus square root of 4. Now we can extract the square root of 9 and square root of 4, since we know that square root of 9 is equal to 3. And we have here square root of 6 plus square root of 6. So going back in our laws in addition and subtraction of radicals, we can combine similar terms provided that their radicands are the same. So applying this here, so since they have the same index and the same radicand, so what we'll have is, imagine there's a 1 here and there's a 1 here. We're going to add the coefficients. So what we have is 2 square root of 6. And then square root of 4 is equal to 2. And furthermore, we can simplify this by adding the constants. This is equal to 5. Why is it 5? We have 3 plus 2. That's going to give us 5. 5 plus 2 square root of 6. And that's pretty much our answer for number 3 letter. Okay, so that's for the letter A if they have the same index. So let's proceed to letter B. What if they don't have the same index, right? So what if that happens? What if that happens? Let's see here. Okay, so this is our letter B. Letter B states that to multiply radicals with different indices, what will we do? So convert them first. Okay, be with me here. Convert them first to the same index and proceed with the multiplication, which is shown in letter A actually. This is in letter A. We will just follow that. And we will be recalling fractional exponents and laws of exponents when we will convert them, when we will be converting them to the same index. So for instance, let's have one example here. Let's say we have, let me write that first. Let's have this one. So for number 1 example, for our first example, what do we have? Cube root of 2 times square root of 6. Okay, so that's our first example. Let me write down the other examples down below so that it will be ready when we go down. Okay, that's enough for now. Let's go and answer this problem. So we have cube root of 2 times square root of 6. So by our law in letter A, we cannot combine them since they don't have the same index, right? So these have an index of 2 here, which is hidden. And here we have 3, so they're not the same. So what we're going to do is to put them back in exponent form first. So remember, this is the denominator, this is the numerator here, which is 1, right? So the first term here is actually equal to 2 1 over 3, right? Times 6. And this 6 has a 2 here and a 1 here. So therefore, this is going to be 1/2. Now, we would want is to put them in the same exponent. That is, making the exponents, the fractional exponents to be exact, similar. They need to be similar for us to combine them. when we put them back in the radical form. So how do we do this? So going back in our fraction, in our lessons in fraction, how to make the fraction similar. So we need to find the LCD. So we have a 1/3 and 1/2. So their LCD, as you will know, is 6 actually. So since that's the least common multiple of both 2 and 3. So 6 divided by 3 is going to be 2 times 1, that's going to be 2. So 2 over 6 is equivalent to 1/3. And 6 divided by 2 is 3 times 1, it's going to be 3. So 3 over 6 is 1/2. So as you can see, they're now in the same denominator. So that's 6. So this is equal to 2 raised to 2 over 6 times 2 raised to 3 over 6. Now, we can put them now in the radical form because they have the same denominator. So by that, the same denominator, meaning they have the same index. So we have 2 squared here. Sorry, this should be 6. My goodness, my bad. This is 6. Okay, so then 2 raised to 2 uh, sixth root, and we have also the sixth root of 6 raised to 3. Okay, now let's try to simplify this. That is 2 raised to 2 is 4, correct? So we have the sixth root of 2 raised to 2, which is 4, and times the sixth root of 6 raised to 3. I don't know what that is. So we have 6 times 6 is 36. Multiply that by 6. 6, we have 18, we have 36. Add them here. 36. Add it here. So we have 216. I think that's correct. That's familiar. 216. And then since they are now in the same index, so meaning we can multiply the radicands together. So we have 216 times 4. Let's try 216 times 4. So what do we have? It's 8, 862, or 864 rather. Is that correct? Okay, 864. So I think, yeah. So this is equal to the sixth root of 864. That's our answer for number 1. Okay, so that's how you do it. It's quite it has some steps before we can go to letter A, only that we need to make sure that the denominators, the indices, are the same. So by using this method, let's proceed to the second one. um the second example states we have the fourth root of 9, okay, times the square root of 27. Fourth root of 9 times the square root of 27. Again, let's put them back in fraction form. So we have 9, sorry, 9. There's a 1 here, right? So we have 1 over 4 times 27 1/2. Okay, so let's make the fractions, or the fractional exponents similar. So we have 1/2 and 1/4. We know that the least common multiple is a 4. So therefore 1/4 is still 1/4, but 1/2 is going to be 2 halves. So this becomes 9 raised to 1/4 times 27 raised to 2 halves. Since they are in the same exponent right now, so we can put them back in the radical form. So we have 9 raised to 1, that's still the same, times the fourth root of 27 raised to 2. 27 raised to 2. Now we need to do some maths here. We don't need to do anything with a 4, or with a 9 rather. So we have the fourth root of 9, just copy that. But we need the fourth root of the 27 squared. So I need to 27 times 27. So 27 times 27 is going to give us what number? 4, this is 14 plus 14, that's 28. That's going to be 49. Therefore, the answer is um, 729. Is that correct? 729. Okay, 729. Okay, so I think we can get that 729. 729. Okay, 729. Okay, and then what we'll do is we're going to multiply 729 times 9. So let's do that. 729. It's quite a big number. Okay, yes. Let's do that. 729 times 9. So what is that going to be? That's going to be 7 times 9 is going to be what? 63. 9 times 2 is 18. 9 times 9 is 81. Cannot put that below. So the answer is 6, 5, 6, 1. 6, 5, 6, 1. Okay, wow, that's a big number. Let's put it here. 6, 5, 6, 1. So we have the fourth root of 6, 5, 6, 1. Okay, maybe you can think of a moment if you can see any number which has a fourth root of 6561. Okay, can you find anything? Just fourth root of 6561. Let's try this. Okay, I'm just going to give you a hint already. So we have 9 squared is 81. Um, this is 9 squared, right? Let's put a block here. 9 cubed is actually well, let's try 81. Let's try to verify. 81 times 9 is going to give us a 72. So 729. 729. But how about 9 to the fourth? So 9 to the fourth is 729 times 9. 729 times 9. So that's gonna give us 7 times 9. It's over here. 7 times 9. 729 times 9 is going to give us 6 6561. Okay, so if you just want to do that again, so we are 18, 81. So therefore, we can see that this is 6, 5, 6, 1, which is equal to 4. Or rather, sorry, 9 rather. Equal to 9. Okay, so therefore, our number 2 is equal to 9. Quite a big number for us to check if this is indeed a fourth root, but hey, it's 9. Okay? Okay, last number for the second example. Last number, let's have number 3. Um, number 3. Okay, so for number 3, what we'll have here is going to be the third root or the cube root of 16 times the square root of 32nd. Okay, let's try to answer that, shall we? Okay, so let's convert them again to fractional exponents. So we have 16, um, there's a 1 here, so 1/3 raised to 1/3. And we have times 32 raised to 1/2. So we know that the the LCD of 1/3 and 1/2 is 6. It's gonna give us 16 raised to 2 over 6 times 32 raised to 3 over 6. Again, why did we have that? Because 2 over 6 simplified is 1/3 and 3 over 6 simplified is 1/2. So let's put them back in rational forms. So we have the sixth root of 16 squared. Okay, sixth root of 16 squared times the sixth root of 32 cubed. 32 cubed. Okay, now what we want to do then is to simplify this, but we would want to know something before we would be simplifying. Okay, because this is going to be a big number. Okay, this is going to be a big number. So we can do some laws of exponents. Okay, be with me with this. So we know 16 and 32 are both powers of 2. So meaning we say 2 squared is 4, 2 cubed is 9, 2 raised to 4 is 16, and 2 raised to 5 is 32. So they're both in powers of 2. Therefore, let's convert them to powers of 2. So 2 raised to 4 raised to 2 times sixth root of 2 raised to 5 raised to 8. What are we doing then? What are we doing then? We will be combining them by the power of the power law. So we have sixth root of 2 raised to 8. We multiply exponents times the sixth root of 2 raised to 5 times 8. Okay, 5 times 8. Or rather, why is it 8? This should be 3. My goodness, my bad. This should be 3. Right, because it's 3 here. So 5 times 3 is going to give us 15. Okay, let's put them under one roof, that is under one radical sign with the same index. 6th root of 2 raised to 8 times 2 raised to 15. What we'll do then, by the power or law of product, so what we'll have is the 6th root of 2, since they have the same basis, we can add the exponents. 15 plus 8 is going to give us 23. Okay? Now, what we can do is to separate or factor out this 2's in such a way that we can extract it from by the 6. So this 2 raised to 23 can look like, okay, it can look like 6th root, we'll use the next line. This can look like the 6th root, sorry, the 6th root of 2 raised to 6 times 2 raised to 6 times 2 raised to 6. So we have 6 times 6 plus 6 plus 6 is going to be just 18. So the excess is actually 2 raised to 5. I'm sorry, it should be like this. Okay, so all of these 2 here, which is raised to 6, by one of the law of radicals or principles of simplifying radicals, we can extract them. So what we can have is 2 times 2 times 2 outside. Why? Because we did cancel this. Okay, so we have 2 times 2 times 2, square root of 2 raised to 5. And we can further simplify this by making this 2 times 2 times 2 is 8. Okay, is 8. And 2 raised to 5 is going to give us 32nd. So therefore, our final answer for this number 3, okay, which is the cube root of 16 times the square root of 32, is going to be 8 square root of 32. Again, 8 square root of 32, and that's our final answer. So that's it for this video in multiplying radicals. I hope you learned something today, and I hope that you will also hit like and subscribe. So thank you very much for watching.